All right, so welcome everybody today to our discussion on the power of interoperability, enabling digital transformation in life sciences. My name is Adam Reba, Director, Laboratory Informatics Services at Asterix. Just a little bit about myself. So about 15 years in the industry. Really, the entirety of this time has been working with professional services organizations, incorporating the scientific needs with the software solutions that you see available today. For about 10 years of this time, I was working directly with the vendors, but now at Asterix, really the benefits of it is being vendor agnostic, being able to not only focus on trying to force a particular requirement into a single product stack, but being able to really help and work with the customer on what's really best for them. I'm joined today by Jeff Gerhard with Cytera. He's Chief Technology Officer and co-founder. Jeff, you want to say a little something about yourself?
Sure. Yeah, so Jeff Gerhard, like you've had a long time in the industry. I don't know how many years now, 35 years in sort of the lab space. I'm trained as an analytical chemist, and I worked with the vendors a lot myself. But my co-founder and myself found an opportunity here in the digital lab space to be like Asterix, vendor neutral, and provide a data exchange platform that could normalize a lot of the activity that's in the lab. So yeah, happy to be here with you.
No, it's great to have you. Thank you so much. So as we dig in today, we're really going to kind of look into, like I said, the components of how do we really digitize the lab? Where are customers truly at today? What are some of the challenges that they have? So as you can see on the slide here, we're kind of going to look over some of the components that kind of build into what builds out a true digitalized lab, right? And first to really start off, before we dig into each of those components, really looking at what are the four main items that we kind of identify as like a true need, having a plan in place to be able to accomplish this. And this falls along with things like capability, right? It's a place where like Cytera comes into play, being able to give that technical functionality that's enabling what the scientists are really looking for. It's not something that in the past has always existed. It's something that's always forever moving. So it's great to keep up with what is available and knowing that. The next thing is having that direction, being able to be advised appropriately, to be able to know what they should be focusing on first, right? There's so many different acronyms, so many different systems available today that customers don't always know what the best first thing to focus on is, and just being that advisor to be able to help with what's going to really give them the largest benefits as early on as possible. Of course, the next thing is having the appropriate team. It's great. Some customers have really excited and energetic SMEs that are capable of taking on some of these, the technical side of things. Even though science is their main focus, they actually have some great SMEs as well. But it's pretty common that customers really need that exterior help to be able to truly understand, again, what's available, how do you implement it, right? How do I create a particular function, integration, report, whatever it may be? And the last thing is having a process that's really proven, really works. It's something that really enables customers to run effectively and efficiently as they kind of navigate through their roadmaps.
So when customers come to you for this, are they usually coming at a sort of a broad corporate level saying, we need to modernize things? Or is it at a much more micro sort of project level?
We see a little bit of both, and it really depends on who you're talking with, right? Really, the project sponsors overlooking might not have a real idea of what are the true things that are in place at the lab. They may not have that level of detail, and they'll come to us looking for more of that higher level roadmap. What direction should we be going? And then, depending on who we're working with in the customer, when you get down into the business, working with the SMEs themselves, you start to experience that you're getting a little bit more into that nitty gritty, right? Yeah. To really talking through what are the true user stories, what are the true requirements that need to be implemented, and being able to help guide, okay, instead of saying this is the next system that you want to implement, it's more focused on this is the next process, this is the next requirement that really would give your users the benefit.
Yeah. So you've sort of broken this down into the different things that have to be, you have to be in. You're saying that things like reporting, that's sort of one of the first things people start with.
That's exactly right. So yeah, reporting is kind of one of those easier wins. Like I mentioned, the goal is, a lot of people at some point in paper, they're trying to now digitize it. But once it is digitized, where can I get value back the quickest, the easiest, the simplest? And starting off with things like reporting is a great place, right? There's a lot of reports that need to be generated, need to be tracked, give visibility outside of the particular end users, right? Giving it up through that organization to be able to understand what's actually being used. How is it being used? What is the data that's coming out and being able to pull it out of that system?
Yeah.
And so kind of following that and kind of going on a similar line is that searching capability. So this isn't necessarily just receiving a PDF or a report itself. It's given that little more interaction to the data, right? Being able to go into a system, do some filtering, some organization, some little modifications against that data that now is finally captured into some sort of lab system, and being able to find things quicker, navigate around, give that visibility across the groups, across the organization, to be able to search with something that may not be available in those reports, but the data we know exists within the applications themselves. Yep. And so then being in a regulated space, of course, the next thing that follows, and this luckily nowadays, a lot of the software solutions today come natively, but sometimes they need a little bit more of an expansion from what's available, is the audit history, right? It's so important for us to really understand who did what, when did they do it, how did they do it, being able to capture that, being able to defend it, should there be some sort of audit, and just being able to also track back on history, being able to look back of, what were you accomplishing, where were things changing, so that you can always continuously improve. This is all focused on how do we improve, how do we become more efficient, how do we become more effective and accurate.
Yeah.
So now once these are kind of in place, we kind of fall into this next space where I think is where Cytara really kind of starts to give the benefit and really be able to incorporate some of their solutions within the lab and be able to provide that value. And the first thing that customers look at, and this is where we start to get into where customers truly are today, and this is instrument integrations, right? We have our various lab instruments that now we need to collect and capture data from. Historically, we've been writing it down on paper notebooks or typing it into a particular method or whatever, your experiment, whatever it may be. The benefits of actually fully doing integrations with these instruments themselves really provides a lot more of that automation and that value that you truly need and want to help support with the things to come. So with that, do you want to touch a little bit on some of the integrations with instruments themselves that you see with Cytara?
Yeah, sure. Maybe good to get better understanding what, for you, instrument integrations, one thing you mentioned, a lot of people think that's just getting data out of the instruments, but it's really bi-directional. It's not having to go over and type in that sample set as well, just to set the instrument up. Ideally, you like to have that, sent to the instrument. You just use the instrument for the analysis, and then the data is then extracted out without having to copy it onto a USB stick or, write it down or print out a report and then copy that somewhere. So is that what when you think of instrument integration, it's a sort of whole bi-directional setup, and then we're getting the data from it? Yeah,
absolutely. And it's really going to be custom fit dependent on the instrument. I kind of fall instrument integrations into basically three categories. You have your non-connecteds, right? Your pipettes, your timers, things that you're not really capturing data from. So there's no true integration, but you still want to be able to track it within a system. And then we fall into the space where you're touching on is where you come unidirectional or bidirectional with things like direct connect instruments, your balances, your pH meters, things of that sort. And then we fall into the file-based, right? The more complex system, your UPLCs, your titrators, whatever it may be, that are spitting out more dynamic reports that are adjusting, that we got to be a little more flexible and be able to read. With that, I always laugh when you brought up the thumbsticks that used to exist. We refer to it as sneaker net, right?
Yeah.
Having to be able to bring it over to your computer to plug it in, getting out of that, moving into the more modern world to being able to read those files accurately and appropriately.
Yeah, and then when you talk about systems integration, the next one on there, what does that mean to you and your customers?
Yeah, so system integrations themselves kind of fall outside of instruments. And sometimes people kind of look at instruments is it a system? Sometimes they kind of are. But what I'm referring to when I say system integrations is connecting all these different lab systems, right? Most people today have ELN, LES, QMS, SDMS. You can go on with the list of acronyms. How do we make it so this is a single unified workflow that everyone's following, right? That everyone's able to move through, so that when I'm in the lab, I'm not having to copy or transfer data manually. I'm being able to take these various lab systems and integrate them in a way that they're able to talk with each other. So it removes that need for that manual function or operation that happens today.
Okay. Well, so yeah, let me talk a little bit about what we did. And so when we started Cytara, this is sort of the environment that we saw exist in the lab, that there was a real need for giving the tools that make this instrument integration and system integration easier. So we created a cloud-based platform. You see on the screen here that Cytara DLX is a cloud-based. Quite often we host it on AWS, but it's sort of cloud agnostic. It can be a single or multi-tenant. It's a microservices architecture that's typical to a lot of SaaS-based solutions. We provide connectivity into a lot of the cloud-based lab assets that exist now, just the regular business assets, like a lot of things people want to be able to transfer from their Office 365 Excel or Box account or push data into Snowflake. We provide connectivity into those. A lot of lab IT platforms now have been moved to the cloud. We've got a lot of the ELNs, Benchling, Signals, IDBS Polar that are cloud-based now. And a lot of the LIMS systems have moved. They're not on-prem anymore. They're cloud deployed. So we provide connectivity into those. A lot of our customers also want to be able to connect into cloud-based assets. They may have data lakes or repositories or databases they want to connect into. So we provide connectivity layers into those. But probably more importantly, we provide the connectivity into the on-prem space in the lab. Simple things like a balance or a pH meter. Quite often those have very limited connectivity. An RS-232 port they might have, let alone any sort of cloud-based connectivity. We have technologies that allow you to connect into a lot of these simple devices and then ultimately connect into the cloud. Similarly, more sophisticated instruments, HPLCs, bioreactors. We have a whole range of connectivity that allow those also to be connected in on-prem and then ultimately present themselves to the cloud-based solution, just like the cloud-based technologies like the ELNs. So once they're all connected, they appear as peers on this exchange. It's particularly with a large enterprise pharma, one of the real tough things is the network environment that these are in is usually a highly protected, walled-off space. And so we've had to develop technologies that allow us in a very secure way to be able to allow these to be connected and in a real-time fashion present themselves in the cloud in this secure way. So that's something we spent a lot of time. A lot of our enterprise pharma customers have helped us define that solution and create ways that we can allow these on-prem lab assets that are highly protected to exist in the cloud as well.
Yeah, and that's great. Kind of continuing on that, that's really enabling, again, going back to giving the scientists something that they're not aware of, right? Yeah. Everyone has this desire, and everyone's really moving to the cloud, and whether it's self-hosted or some sort of SaaS solution, they don't understand the technical restrictions to it, right? Oh, it's great, I'll move to the cloud. Well, what about all the instruments that are not on the cloud, right? They're physically in your lab, and that's exactly what this is opening up and really enabling. And that falls right onto that first of the 4 points, the capabilities, right? Having the technical capabilities existing today to be able to open up that true interoperability in the lab.
Yeah. So, another way that we like to think about this is, so this is what the lab looks like now. It is a collection of on-prem devices as well as cloud-based devices. You have people in the lab that are trying to access this information. And right now, there really is quite a heterogeneous, non-cloud, often very poorly described interfaces to all of these. If you want to interface with that balance, you got to go get the manual and read what it does, or even some of the cloud-based ELNs, you need to go and understand that particular API. What we do is we provide that connectivity. We work with all the vendors to understand the connectivity that they offer and create adapters that they can present themselves in the DLX system. And once you've done that, on top of this now, you have a very normalized, cloud-based, consistent, schema-described, event-driven interfaces. And on top of that, we've built these tools that you can use. Right now we have orchestrations, which what I think of orchestrations, they're just automations. They're event-driven. It could be a timer goes off, and then you go and check a bioreactor and report back and email you the results. You can create an orchestration to do that. Or it could be a user has created a table in Benchling, and they want to send that as a sample set to Empower. That could trigger an automation that would do that. And the connectivity we provide allows that table to be reformatted and sent to Empower as a sample set. Or data is ready in an instrument, and it'll post it back to that ELN. So those orchestrations are these sort of linear automations. Well, a lot of us do this in our homes right now. When you walk in, you press your doorbell, it turns your thermostat to it. It's essentially what we offer now, now that you have all this connectivity. Workspaces is a new platform that we're developing that is essentially allows you to create these dashboards where we allow you to drag visual elements, a table, a graph, a button, and connect them to any things that exist in your lab. So if you have a bioreactor going, you may want to create a dashboard that allows you, when you're at home in your living room, to say what's going on in my bioreactor when you're on the weekend, and it shows you a full graph of the current conditions. There's these sort of live dashboards that you can create. The last one is agents. Maybe we'll talk to this in the future. This is where we're really excited about starting to allow AI to be able to be applied in the lab. All the tools that have AI. What is missing to do that is this connectivity, this well-described interface that AI can see and really start to apply that. So really, it's now that we've built these tools, hopefully it's folks like you that can use them and provide that connectivity in the lab now to really enable a lot of the things that your customers are asking for.
Yeah, absolutely. And I'm assuming with these connectors that you have with these instruments, it's a list and it's a catalog that you're constantly growing. But like you said, every instrument's different. There's always something new out there, and it's exactly that. So a place where Asterix can come in, be able to understand that particular instrument, and build out these additional connectors to be able to build out this catalog even further, right?
Yeah, it's almost like boiling the ocean to say, okay, we're going to provide connectivity for all those assets in the lab because there's so many of them. There's a long tail of small things, and the lab is very fond of keeping instruments for years and years and years because there was a regulated method they used for that, and they have to retain that one. And so we have to be able to provide connectivity for that old, system that runs on Windows 95 and drops a file into a directory. So the way that we've tackled this is we have some built-for-purpose connectors, things like Empower or Chameleon that have a particular API. We built a special connector for that and work with the vendor. But there are a whole lot of ones that use RS-232 or OPC or a file drop that we build a more of a generic interface for those, and then we let service providers like you configure a connector that actually gets published as a connector. So Agilent ChemStation may drop a file of a particular format. You could configure a connector that's going to parse that in the way that you wanted, and it's going to look like a connector. You can then publish that, or when you can use this for other applications. And so we're creating a user community that all these connectors they've configured get published to there, and that's the way we're going to boil the ocean. Allow our users to configure these and then save these to the community, and then expand that connector base. So it's a combination of these sort of bespoke connectors and configurable ones that we think we're going to be able to boil this ocean and provide all that.
It's quite the undertaking, that's for sure. But you brought up a good point too with this. So creating file parsers is something we do today, right? But kind of like we mentioned, every lab has so many different applications, maybe from 10 different vendors. Being able to, what we do today is building out these parsers for each particular vendor. What your solution really provides is that capability of building out if it doesn't exist, or just leveraging what already does exist to be able to have it available across the entire IT ecosystem at these particular customers. And that's definitely a large value that most probably don't recognize.
Yeah, file parsing is one of these things, and again, because the lab, quite often the way that instruments in software gets data is by file exchange. Parsing is one of those things that has always been difficult. We're really later this year, we hope to introduce this cool visual parser that allows you to, look at the file, drag and drop sections that you want, and then ultimately, after you parse it, you want that to output JSON data that you can then use in another part of the automation. And so this is going to be a real cool way for somebody to just go in and easily create a parser, save that, and as a method that they can share with somebody else. So.